All right, the purpose of this lesson is to review the definition of continuity. A function f of x is said to be continuous at a value x equals a. The following criteria are met. Number 1, f at a must exist. That is, if we replace x with the value of a, we must get a real number for y. 2, the limit as x approaches a of our function must also exist. And number 3, f at a must equal the limit as x approaches a. Now technically, if this last statement is true, the first two statements have been met. Press the arrow key to go to the next slide. Okay, so now let's look at an example. We want to show that the function f of x equals the square root of 4x plus 1 is continuous at x equals 2. So step 1, we need to make sure our function exists at the number x equals 2. So we replace x with 2, we get 8 plus 1, square root of 9, and that's 3. So we get a real number, therefore the function exists at x equals 2. Step 2 is we now need to take the limit as x approaches 2 of our square root of 4x plus 1. Since the square root of 4x plus 1 exists immediately to the right and to the left of 2, we can replace x with 2, and again we get 3. Since f at 2 does equal the limit as x approaches 2 of our function, we can say that f of x is continuous at 2. Press the arrow key to go to the next slide. So our next question is, for what values is our function f of x equal to the square root of 4x plus 1 continuous? Well, we want to make sure that the function exists at different numbers for x. So the first thing we're going to do is check domain. Since we want to take the square root of positive numbers or 0, we're going to make sure that 4x plus 1 is greater than or equal to 0. And that would mean that x is greater than or equal to negative 1/4. So now we know if we pick any number greater than or equal to negative 1/4, we're going to make sure that then f of x is a real value. Now essentially we need to look at two pieces of that domain. The first question, or the first part, is f of x continuous at x equaling negative 1/4? Well, the first thing is, does f at negative 1/4 exist? Well, we know it exists because we've defined it as part of our domain, and the value of that would be 0. The second part is, does the limit as x approaches negative 1/4 exist? Well, here's where we may have some problem. There are essentially two halves, or two sides of the negative 1/4. There is the right side, so x is approaching negative 1/4 from the right, and then there is the left side. X is approaching negative 1/4 from the left. Well, from the right side, we really don't have a problem, because from the right side, that means x is greater than negative 1/4. So here we can actually get a number, and the answer here would be 0. Now we do have a problem for less than negative 1/4, because we're not allowed to choose numbers less than negative 1/4 and get a real value. So here, the left side does not exist. So therefore, the limit as x approaches negative 1/4 does not exist. And so f of x is not continuous at x equaling negative 1/4. Press the arrow to go to the next slide. So now we're ready to look at the second part of our domain, and that is for x greater than negative 1/4. So we're going to let a be some number greater than negative 1/4. So is f of x continuous for those numbers? Well, because x is greater than negative 1/4 was part of our domain, f at a, the first part of our definition, must exist. Second part is now we need to figure out the limit as x approaches a of our function. Now, unlike negative 1/4, a, we know, is greater than negative 1/4. So therefore, we know if we looked to the right and to the left of a, the value function would exist. So this, therefore, would equal the square root of 4a plus 1. So f at a does equal the limit as x approaches a. Therefore, f of x is continuous at x greater than negative 1/4. And now it's your turn. Make sure you've taken the notes on this video and complete the worksheet. So let's assume